Lizard, such a small word, yet behind it lies one of nature's most extraordinary survival machines. From scorching deserts to mist-covered rainforests, from dusty home walls to hidden mountain valleys, lizards have conquered almost every corner of planet Earth. Most people think of a lizard as just that tiny reptile clinging to the wall, but the truth is far deeper. A lizard is like a walking, breathing science textbook, teaching evolution, biology, physics, and survival in real time. Lizards belong to the reptile family and are one of the most widespread animal groups in the world. Scientists estimate that more than 7,000 different species exist today, making them one of the largest reptile categories known. Their success is not because they are powerful in size, but because they have mastered something far bigger than strength: adaptation. One of their defining traits is that they are cold-blooded, poikilothermic creatures. This means they cannot produce internal heat the way humans do. Unlike mammals, who maintain a stable temperature regardless of weather, lizards rely on the environment to control their body heat. In the early morning, when the sun gently rises, many lizard species can be seen lying over warm rocks or stretching their bodies wide to absorb heat. Their scale-covered bodies act like tiny solar panels, soaking warmth to activate their metabolism. When a lizard warms up, everything inside them begins to run faster. Their reflexes sharpen, their blood flows smoother, digestion becomes more efficient, and their hunting skills increase dramatically. And when the sun becomes too intense, they cool down just as intelligently, slipping into shade, burrows, crevices, or cooler soil to avoid overheating. This daily temperature routine is a lesson in energy-based survival. Sometimes the key to life is not power, but management. Their skin is covered in keratin-based scales, which serve as a protective armor. These scales guard their bodies from injuries, dehydration, dust, and predators. Unlike snakes, who shed their entire skin in one piece, most lizards shed in small patches, bit by bit. This molting process helps them renew their outer skin for growth and remove parasites that may be clinging to them. Their scale pattern, size, shape, and alignment act like a biological identity card. Each species carries almost a unique fingerprint-like scale arrangement, helping scientists identify them. Lizards also possess surprisingly advanced eyes. Many species have strong color vision, and some can even detect ultraviolet light wavelengths, helping them track insects, interpret body signals of other lizards, and navigate their surroundings better. Geckos, for example, mostly hunt at night, and their vision system is incredibly optimized for low light. Their retinas can detect small moving insects, even in near darkness. Their pupils are shaped like vertical slits, allowing controlled light entry and razor-sharp focus at night. In contrast, day-active lizards have round pupils to handle brighter environments. Another myth people often believe is that lizards are deaf. The truth? They do not have outer ear flaps like mammals, but they have tiny ear openings behind their eyes that capture vibrations. Some desert species can even sense movement through ground vibrations, detecting steps of predators or prey from a long distance. Their hearing may be hidden, but it is present, highly functional, and deeply connected to survival. Perhaps the most dramatic survival trick a lizard owns is known as tail autotomy, or self-detaching tail defense. When a predator, like a snake or bird, grabs a lizard by its tail, the lizard can break off the tail along special fracture planes in the vertebrae. Even after falling off, the tail keeps wriggling, distracting the predator like a decoy toy, while the lizard escapes within seconds. But this escape comes with a price. The tail stores fat reserves, meaning the lizard sacrifices energy to save its life. Over time, the tail regrows, but it is made of cartilage, not the original bone structure, meaning the new tail works, but is not exactly the same as the old one. This tail regrowth can take weeks or months, depending on species, food, environment, and health. Lizards' movement systems are also worth studying. Most species have 4 limbs and walk in a sprawling gait, meaning their legs extend outward rather than downward like mammals. But some species, like glass lizards and slow worms, are legless and move almost like snakes. The champion climbers among them are geckos, whose feet contain microscopic hair-like fibers called setae. These setae create molecular-level attraction using van der Waals forces, allowing geckos to stick on smooth surfaces like glass, ceilings, and tiles with ease. This adhesion is not glue, suction, or moisture. It is pure physics at atomic interaction levels. Engineers have even studied gecko feet to design future adhesives and climbing robots inspired directly by nature. Their food habits vary between species. Most lizards are insect eaters, insectivores, controlling populations of mosquitoes, flies, small beetles, ants, and pests. Some are omnivores, and others, like the green iguana, are mostly plant-based, eating fruits, leaves, flowers, and greens. And then comes the giant, the Komodo dragon, which is technically a monitor lizard capable of hunting mammals as large as deer, pigs, goats, and even buffalo. It carries venom-like compounds in its saliva to weaken prey, combining both predatory patience and biochemical advantage. Reproduction among lizards holds even more twists. Most species are egg layers, oviparous, producing leathery shelled eggs instead of the hard calcium shells of birds. Some species, especially those in colder regions, give birth to live young, viviparous, because eggs would not survive in freezing environments. One of the most shocking reproductive techniques is parthenogenesis, seen in certain whiptail lizard species, where females produce genetic clones without mating with a male. Natural cloning offers these species a reproductive edge when males are rare or absent in certain habitats. One cannot talk about lizards without mentioning chameleons, the color-changing masters. But contrary to popular belief, most chameleons change color not primarily for camouflage, but for communication, temperature control, mood expression, and dominance display. Dark colors absorb heat when needed, while light colors reflect solar intensity. Lizards also live under complex behavioral rules. Some species exhibit territorial aggression and hierarchy, especially anoles and iguanas, who communicate using colorful throat flaps called dewlaps, head bobs, push-ups, body posture, and color intensity. Their body language is a silent reptile broadcast channel, sending messages without sound. Their hearts typically have 3 chambers, unlike mammals who have 4. But in monitor lizards, a partial wall improves oxygen separation, giving stronger stamina during hunting or running. They breathe using lung sacs without a diaphragm, pushing air through rib expansion and throat pumping, proving once again that survival has multiple engineering blueprints. Lizards are both predator and prey in ecosystems. Birds, large reptiles, mammals, spiders, and even some insects hunt them. Yet they still thrive, because they hide, escape, climb, adapt, regrow, reproduce efficiently, and use the very environment as their tool. A lizard may not roar like a lion, but it does something greater. It survives through strategy. When its tail drops, it teaches sacrifice and return. When it warms under the sun, it teaches energy economics. When it climbs glass, it teaches molecular physics. And when it clones itself to continue life, it whispers one of nature's deepest truths. Survival was never meant to be a battle of size, but a masterpiece of adaptation.